that's what you do. You get smaller and smaller boxes to try and get nearer and nearer reality. And over the last 2 decades, what's happened with these sorts of box models is that, of necessity, they followed that pattern. And it's been a sort of way through. But increasingly, what's happening now, and you'll see it probably in the latest IPCC report, is that there will be issues saying, I think we don't, we've got to be real, that there's no point in trying to get any smaller, because it's not actually telling us any more than we need to know. There are other questions that they'll raise, but it also, you will then say, right, we should be using supercomputers for other things other than climate. But you will find that science moves in the way that, well, the Japanese have got a bigger one, so I think we'll have one as well. And the Americans will say, we can't let the Chinese have a bigger supercomputer than we've got. And these are the guys who are running the supercomputers. They know what they're doing. So we must have a bigger supercomputer with greater power, so that if we need it, we can use it. And this is, it's easy to sort of see modelling as you look inside it and you get better and better and better at it. But the reality of it is that this is an area of the whole atmosphere-ocean issue which is actually bringing in other sorts of questions now about the level of understanding and knowledge that we actually want. And a lot of it is, I say, it's the Jeremy Clarkson approach. If you can do it, because you've got a big enough computer that goes fast enough, and you call it Arthur or something, then yeah, you do it. You don't ask yourself the question, is it worth doing it? Because that's where we've got to. And it is, the astonishing thing is that this has moved on quite so fast and quite so amazingly from the over 50 years, and especially over the last 30 years since the 1980s. If you consider that the sort of thing which in the 1980s general circulation models would take huge computers, big rooms of them, you would now do probably on your phone. Now, that sort of technological change has influenced the whole direction of climate modelling in many ways. So the issue really is very much about at what point do you try and get to the point where you say, right, okay, we have got to ask different questions, because models are responses to particular questions. So the other way you can run a model is, how do you decide how long to run a model? So you want to project into the future. How many years would you project for? Every extra year takes, say, an extra 2 days. And if you, just as a figure, you could say it costs £10,000 a day to run, or more, £20,000 a day. So that's an extra 40,000. So your being able to be asking you that particular question. So how far do we project these into the future? And why do we make that decision? So how far would you say, right, let's project it into the future by a certain amount of time?
You could run the model for maybe 10 years and then see how accurate it is by 5 years if it starts to...
What do you mean, how accurate it is? How do you know if it's accurate after 5 years?
Well, you wait for 5 years to pass and then you
match observation.
if it's...
So you sort of run it, say, well, run it for 5 years, and then in 5 years' time we'll see if that worked. But everything's moved on from then. When you run a model now, the projected models for climate change, effectively they are run into the future. And there again, one of the big questions is, how long into the future do we need to run these models? Because we could run them to 2300. You just leave it running. And you just go on and on and on, and it churns out more and more information. It's very interesting. Tom?
Sure, you're better to run it into the short term though, because in the short term, that's the impact that's going to impact people at the time. So you know what's going to happen in the short term, bit by bit.
Yeah, the problem with that is that when you run a model, models take time to sort of stabilise and equilibrate, and you're not sure what one of the advantages of doing it over longer time periods is that any short-term variability while the model sort of gets itself sorted out and gets the system going is a problem. So you do have to run it for, say, 5 or 10 years to make sure that because it could go in other opposite directions.
When you
When the models run though, do they take into consideration that like parts per million or whatever could increase in 10 years? Well then say it goes
Now
up
the
to
model will
400
run
now.
according to what you tell it is going to happen.
So
We'll
you
see about
could
this
put
next
in
time.
an
I'll show you
increase.
the ways in which that happens. So you feed into assumptions about what's going to happen over a time period, and then you run it. You make those assumptions about how much solar radiation, how much greenhouse gas, etc. But the question really, which is the technical one, is how long do we run it? Do you want it till 2030, 2050, 2100, 2200? Which boils down to the question of what is the purpose of running the model? Which boils down to the question of communicating the information, because this sort of modelling is now being used to determine behaviour and policy. So basically, what these projections have done is they are taken on board by governments to try and decide how to modify our behaviour or our policy, especially with regard to greenhouse gas use. So how far do we run it? Because the climate modelers would be happy just sitting in a room and playing with themselves with the model for as long as they want, because that's fun. That's what they're doing it for. They're not doing it, or they weren't doing it because they were concerned about climate change in the future. They're quite happy fiddling with the model and a little bit of coding. Let's change that and see what happens. That's good. So in a sense, that side of it. But the determination of the quality of the module and how long you run the model is really a question of, if you're going to use the information from that model, how far do we go into the future? So how far do you think they have gone into the future in the past? What's the are you aware of sort of projections into the future and how far?
It's
20?
2050.
2050.
It's 2150, isn't it? Some of them go up to like 2150.
Some go to... The initial set was about 2100. It was sort of saying, let's do a century. Which, well, there were two ways of doing it. One was to say, let's run it for a century, because it's a nice number. It's 100, and we can just run it round, and 2100. There's another way. Another way of doing it was to say, well, let's just double CO2 and see what happens. So in other words, there wasn't, how long will it take if we assume we're doubling CO2? But that was one set. But you get 2050, you get 2100. And a lot of the IPCC reports will have printouts for 2100, or the last decade of this current century. Now the problem with that is that 2100 is so far away that your social scientists turn around to you and say, it's meaningless. I mean, I'm sure lots of you, especially the women, will be here in 2100, 105 or whatever, and still another 20 years left to go because longevity is increasing, and you'll be miserable old, great grannies and whatever, and sort of say, I remember what it was like in the 2000s and whatever. But reality is that we don't, 2100 is so far away that it doesn't mean. So you can show these pictures of projected outcomes of, up 5 degrees warming over the Earth and drying up and whatever. But everybody, when you then say to a policymaker, this is what's going to happen in 2100, they'll say, well, I'll be dead by then. I'm not interested in votes beyond then. So it doesn't mean anything. And if I go to Somerset and I say and I'm the DEFRA minister, and I say, 2100 is going to be all right. I know what's going to happen to me. I'll probably get thrown in the water. It's very short term. We have our own short term. And one of the issues, again, with modelling is the time scale which means something to people, whereby it's more sensible to try and model as well as you can to, say, 2030, rather than run the model to 2050 or 2100. If you say 2100, Greenland ice sheet is going to disappear. Sea level is going to be up 5 metres or whatever. People are going to say, well, that's apocalyptic, it's out in the future, I can't pay that. Whereas actually 2030, let's see where you'll be in 2030. So we're talking 16 years on. Gosh, you'll be getting on. Frozen, and you think of what your life profile, your expected life profile is going to be in 2030. Children, jobs, etc., whatever. you can actually then say, and if you say, well, actually, it's going to be 2 degrees warmer, and it's going to be, we're going to have really extreme events, and sea level's going to have risen by so and so, that actually, you can just about equate with that. So, if we go back to the sort of originator of the question, when you're deciding on how to run the model, it will be better, possibly, to run it to 2030 or 2050 at the sort of scale that you can do it, even if you can't do it down to 50 kilometres by 50 kilometres. Because if you take out the academic side of the interest in doing that, you say, actually, that is useful in terms of policy terms. Because I can use the output to try and show what's happening of that. And I'm also reasonably confident that the model is a good approximation of reality. And we'll see next week how you can evaluate the quality of a model in terms of deciding whether you believe it or not, even though it doesn't account for everything. But the underlying point, really, which is the sort of conceptual point, which is a very important conceptual point about these climate models, is what drives them now, because of our levels of understanding of the processes and the basic physics, is the technology that's available. And the technology is driven by finance. The finance is driven by policy, is driven by government spending, largely, and is therefore driven by the popular desire to spend or not to spend. Can you imagine DEFRA, the Minister in charge of DEFRA, going to Somerset saying, I'm sorry, we can't dredge your river because I've just spent £40 million on a supercomputer for DEFRA to use to project climate change for 2100. That's the reality of where these debates are now operating with regard to the whole system. Okay, let's have a quick coffee break, and then probably about 20 minutes continue.